Now we're going to work backwards from the previous examples and see if we can rewrite a logarithm in more of a compact form. So you can see the directions for this particular type of problem ask us to write the given logarithmic expression as a single logarithm. So that's kind of key. And not only as a single logarithm, but that logarithm has to have a coefficient of 1. So here's a nice way to kind of utilize some of the shortcuts we've discovered after doing a lot of these examples. Before we try to write them in compact form, you may want to start off with making sure that all the logarithms have a coefficient of 1. So if you notice, any time the logarithms have a coefficient of something other than 1, that means it was originally an exponent. So you can use that property, it's a little bit of backwards, and move them back to the exponent in the argument. So if you were wondering what that was, remember that was the property where we had log base b of x to the r is the same thing as r times log base b of x, except this time we are moving, I believe we're moving backwards. Well, it's backwards in the sense of how it was originally posed to you. So I'll take time, rewrite each of these log expressions so that now the argument has an exponent. So I believe we have a 6 as the exponent here, minus log base 5 of x minus 3 taken to the power of 2, then minus log base 5 of 9x plus 4, and that exponent is an 8. Now, what's going on here, we can now use our patterns. And anytime we see items or logarithms that have a negative coefficient, that gives us a hint of where they're located in the argument. And anyone that has a positive coefficient, although you won't see it, that means that that particular argument should be located in the numerator when you write it in compact form. The other thing to be careful about is to look at all of your bases and make sure they are the same before you start condensing anything. And we know at this point the base for all of these is 5. So that's good. We can now proceed. So utilizing the shortcut, we can rewrite log base 5. And because you do see minus logarithms, or sorry, excuse me, negative logarithms, that's probably a better way to say it, for sure we do have ourselves a fraction bar. And anyone that had a negative coefficient, those factors would end up being factors of this denominator in the condensed form. The logarithm that had a positive coefficient would be in the numerator. So that's x minus 7 to the 6th. So notice when you write as a single logarithm with coefficient 1, there's only one log with base 5. And then you're just kind of going through and double checking. Any logarithm that had a positive coefficient, their argument would be in the numerator. Any logarithm that had a negative coefficient, their arguments would be in the denominator. And we are now in compact form. So this is useful, especially when you solve equations. So kind of keep that in mind. Practice, practice, practice. We'll see you in the next example.